First, to define what a system of equations is. Here, a system of equations is a set of two linear equations involving two variables. Up to this point, we've mainly worked with one equation at a time, and now we're going to be considering two equations together, and that is a system of equations. For example, 3x plus 2y equals 5, taken together with the equation 4x minus y equals negative 2 is considered a system of equations. A solution for a system is a pair of values for the variables that satisfies each equation. So a solution for this system of equations would be a value for x and a value for y that would work for each equation. So if I figured out the value of x and the value of y and inserted those into the first equation and the second equation, those two equations would both hold up. They would both hold true. To solve a system by graphing, what you'll do is graph each equation. And what you'll find is that the point or points of intersection of the two graphs are the solutions or solution of the system. So there are cases where there are actually more than one solution. There can also be no solutions, but usually there will be one solution. For example, if I were to graph two lines, so if I had equations for two lines and I used each equation to graph the lines and I found that they intersected at this point would be the solution for that set of equations. And if I look, this is at an x value of about 1.5 and a y value of 1.5. To get the exact solution, you need to make sure that you're graphing right on the points. And that is definitely a weakness of this method, is it can be difficult to get everything exact so that you have the correct point of intersection. So anyways, the solution for this would be, this set of equations would be that x equals 1.5 and y equals 1.5. That's just to give you the general idea. In a few minutes, we're going to work out some specific examples using systems of equations. Now, I mentioned that there can be one solution, multiple solutions, or even no solutions. So let's look at those possibilities. A system with one solution is said to be independent. And the situation that I just showed you was an independent system. So if I have my xy axis and I graph two lines and I find one point at which they intersect, then this system is said to be independent. Another possibility is that there is an infinite number of solutions. What this actually means is that both equations are describing the same line. So if I have two equations and I go and I figure out some points and I graph one of the equations, and then I look at my other equation and I go to graph that, and I realize that it's the exact same line, that means that there are an infinite number of solutions. So this would be dependent. The reason there's an infinite number of solutions is that since these are the same line, any point along this line, which goes on infinitely long, any point along this line is going to satisfy both of those equations. So this is a dependent system and it has an infinite number of solutions. Finally, you could have a situation where there are no solutions, and this is called inconsistent. So think about a situation where there would be no intersection between the lines. And what that would be, as we discussed earlier in the course, is a situation where you have parallel lines. And since these will never intersect, there won't be a solution, and this is called inconsistent. So independent, with the graphing method, you'll see an intersection at one point. Dependent, you'll see that you actually only have one line, even though you started out with more than one equation. That is dependent, and it's an infinite number of solutions. And finally, you may find that your equations describe parallel lines. Therefore, there are no solutions, and this is an inconsistent system of equations. Applying what we just discussed in the graphing method to some examples. So for the first one, I'm asked to solve this system by graphing. Well, in order to graph, of course, I need to have some points. So if I take the first equation, and I'm going to go ahead and let x equal -1. Therefore, I will insert -1 as my x value, and then I'll solve for y. Okay, so what I ended up with is my first point, which is x equals -1 and y equals -3. For the second point, I'm going to go ahead and let x equals 0. And I'm not going to do all the algebra, do all the math out, but if you do insert 0 in place of the x, what you'll find is that y is going to equal -6. What I have now is are 2 points, and that means that I can graph this line. So my first point for this line is at x is -1 and y is down here at -3. That's my first point. My second point is that x is 0 and y is right here at -6. So then I need to draw a line based on this, based on these 2 points, and I have my first line. For my second line, I have the equation 4x minus 2y equals 2. Again, I need to find a couple of points to graph. Let's let x equal 0 and solve for y. And that's going to give me minus 2y equals 2, or y equals -1. Therefore, my first point is going to be 0, -1. For my second point, I'm going to let x equal 2. And if you substitute 2 in this equation for x, you'll find that y equals 3. So I have a second set of points. I have 0, -1, and for my second set of points, I have 2, 3. Graphing out this second line. 0, -1 is right here. Second set of points, 2, 3 is right here. Using these to draw my line, what I'm going to find is that I have a unique point of intersection. And it's a bit hard to tell on here, but that comes out as exactly intersecting at -1, -3. Okay? So the point of intersection is -1, -3. And if you had the entire grid, you'd be able to graph it right on and get that -1, -3 value. But the idea is that you graph the lines and look for a point of intersection. So here I have one solution. I have a single solution. X is -1 and y is -3. Both these equations will be true. Again, in order to graph, I've got to find some points. So working with the first equation, 2x plus 3y equals 13. First, I'm going to let x equal -1. That gives me -2 plus 3y equals 13. I'm going to add 2 to both sides. which will give me 3y equals 15, and then divide both sides by 3 to isolate the y, and I have my first point. I have x equals negative 1 and y equals 5. For my second point, I'm going to let x equal 2. If I substitute 2 in up here and work out the math, I'll find that y equals 3. So my second point is x equals 2 and y equals 3. So I have 2 points. I can go ahead and graph this. First point is negative 1. X is negative 1. Y is 5. For my second point, x is 2 and y is 3. So x is 2 and y is 3. Now I can connect these two to form a line and work on my second equation. Negative x plus 4y equals 10. Okay, for the second equation, I'm going to first let x equal negative 2. Inserting it into this equation, that's going to give me minus negative 2 plus 4y equals 10. This is going to become a positive 2 plus 4y equals 10. Isolate the y by subtracting 2 from both sides, which is 4y equals 8, or y equals 2. I have my first point, and that is that x is negative 2, y is 2. Next, I'm going to let x equal 2. I will insert 2 into the equation and solve to find that y equals 3. Okay, so again, I have 2 points for this other line, for the second line. I have negative 2, 2, and 2, 3. So graphing out the second line, x is negative 2 when y is 2, and x is 2 when y is 3. And what you'll see is that I got lucky and picked numbers that gave me 2 points that were the same. So I actually had my point of intersection as one of the points I was graphing, so I'm sure that it's exact, it's right on. So that point of intersection is 2, 3. Therefore, when x equals 2 and y equals 3, both of these equations will hold true. And again, I mentioned you can check that by inserting these values into one of the original equations or even both of the original equations. So let me do that for one of them. To check this, to check my answer, what I'm going to do is I'm going to choose this top equation, 2x plus 3y equals 13. And then I'm going to use the x value I found of 2 and the y value I found of 3. And I'm going to make sure that that works out, which will give me 4 plus 9 equals 13. And it does. Now, if I come up with something that was not true, like 9 equals 13, then I have to go back and look at what I did and really check my graphing. But here it did work out, and I could do the same with the second equation. In this third system, I have 2x minus 4y equals 8, and 3x minus 6y equals 12. So this time I'm going to go ahead and find the x and y intercepts as my coordinates, and that's a good way to use, although with the graphing you sometimes have to do a few points in order to find ones that land on whole numbers, that land on integers, so that you're not dealing with fractions and trying to graph fractions. So sometimes you may have to do multiple points to get one that will give you an exact graph. Okay, so I'm going to find the x and y intercepts, and remember that when you're finding the y-intercept, what you're going to do is let x equal 0. So if I let x equal 0, I'm going to have 2 times 0 minus 4y equals 8, or minus 4y equals 8, which is going to give me y equals negative 2. So my first point, my y-intercept is at 0, negative 2. If I let y equal 0, and then I go ahead and insert 0 in there. Be 2x minus 4 times 0 equals 8. I'm going to work that out and find that x equals 4. So my x-intercept is at 4, 0. So I'm graphing these intercepts. And for the first one, I have 0, x is 0, y is negative 2. For the second one, I have that x is 4 and y is 0. So I have points, one intersecting the x-axis, the other intersecting the y-axis, and I can use that to graph this line. For the second equation, I'm going to do the same thing. 3x minus 6y equals 12. To find my y-intercept, I'm going to let x equal 0. So I get 3 times 0 minus 6y equals 12, which is negative 6y equals 12. Divide both sides by negative 6 to get y equals negative 2. So my y-intercept is at 0, negative 2. When I let x equals 0, y equals 0, I'm going to find my x-intercept. So when I let y equals 0 and solve that out, I'm going to find that x equals 4. So that's 4, 0. You may have already noticed these are actually the same. So if I go and try to graph this second one at 0, negative 2, I'm going to have the same point. And over here, I'm going to have 4, 0. And even if I hadn't chosen the intercepts, if I would have just chosen 2 random points for this first equation and 2 random points for the second, I would have found that those points landed on the same line because these two equations describe the same line. So no matter how I would have done it, no matter what x and y points I picked, they would have landed on the same line. So this is a situation where I have an infinite number of solutions. Any point on this line, which goes on in both directions forever, any point on this line is going to be a set of solutions for these two equations. So that's an infinite number of points, so it's an infinite number of solutions. Solve the following system by graphing minus 2x minus y equals 5 and 6x plus 3y equals 12. As usual, I need to find some points. Starting out with the top equation. Minus 2x minus y equals 5. I'm going to go ahead and let x equals 0, so I'll find the y-intercept. Negative 2 times 0 minus y equals 5. Negative y equals 5. Go ahead and multiply both sides by negative 1. And I'm going to find that y equals negative 5. So my first point is 0, negative 5. For my second point, I'm going to let x equal negative 1. And if I insert that in here, I'm going to find that y equals negative 3. I have 2 points. I have my first point as the y-intercept. When x is 0, y is negative 5. For my second point, I have x is negative 1. Y is negative 3. So I'm all set to connect these points and form a line. Next equation, 6x plus 3y equals 12. I'm going to again let x equal 0. Go ahead and substitute that in for x, which will give me 3y equals 12. Dividing both sides by 3, I get y equals 4. So at my first point, x is 0, y is 4. For my second point, I'm going to let x equal 1. And if I worked that out, I would see that I would get 6 times 1 plus 3y equals 12, or 3y equals 6. And then I'm going to go ahead and get that y equals 2. So my second points, or set of points, is 1, 2. So now I have 0, 4, and 1, 2. I'm going to plot out this second line. When x is 0, y is 4. When x is 1, y is 2. And what I end up with is two parallel lines. Because parallel lines never intersect, there are no solutions. There's no solution to this system of equations. And remember, another way to check your answer on this one, since you don't have a set of solutions to insert, is to figure out the slope, because these two lines are going to have the same slope if they're truly parallel. And remember, if we write this in slope-intercept form, y equals mx plus b, we can find the slope. So for the first one, negative 2x minus y equals 5. What I need to do is move the 2x to the other side and multiply by negative 1, and I'm going to find that y equals minus 2x minus 5. So my first slope is negative 2. So the slope of this first line is negative 2. For the second line, I'm going to also put this in slope-intercept form, the second equation. 6x plus 3y equals 12. I need to move the 6x over to the other side. So minus 6x plus 12. And then I'm going to divide both sides by 3. And I'm going to get negative 2x plus 4. Again, I get this a slope of negative 2. So the slope for this line is also negative 2. So I've verified that these actually are parallel. They're not going to intersect. There is no solution to this set of equations.